As humans and technology continue to evolve, we're one step closer to freeing our rockets and satellites from timely erosion. Florida International University will test a radiation-resistant covering aboard the International Space Station this fall. The majority of materials used not only emit harmful radiation for humans, but also collapse when exposed to it. But it's time to applaud the scientists. They've developed an entirely new radiation-resistant substance. When and which rocket will be used to test the sample in space are unknown. The new material's qualities and chemical makeup are still unknown. This might be a result of the fact that it won't be copyrighted until all the tests are finished. What we do know is that a sample of the new coating will spend 6 months outside the International Space Station before being brought back to Earth. It'll also be put to test using a mixture that mimics lunar regolith. The novel substance is intended to build structures in a vacuum and under the influence of cosmic radiation. But there is a huge reason so much work is being put into this new coating. Apparently, construction on the moon is its primary application, though. That's right, folks. If we ever plan on building a little sanctuary for people, then we need the structure to avoid degradation. It's set to be used in the Artemis program, according to the developers. It is known that the unmanned Artemis 1 mission is scheduled to launch in 2022. The human flyby of the moon is planned for 2024 as part of the Artemis 2 mission. Additionally, after Artemis 3 lands near the south pole of our moon in 2025 or 2026, major infrastructure projects will start to be built there. But it's time to work on a coating that can ward off corrosive reactions and damages. Building materials should therefore possess a wide range of physical, mechanical, and chemical characteristics, while also not being excessively expensive. According to Arvind Agarwal, chair of the Mechanical and Materials Engineering Department and head of the university's Plasma Forming Lab, by attaching the material to the International Space Station, we can simulate the actual radiation that structures on the moon would encounter. In the event that earlier flights are successful, NASA intends to send people back to the moon in the middle of the decade. NASA is currently leading a number of space missions under the Artemis program. There are presently 3 Artemis missions in development. Artemis 1, an unmanned test flight around and beyond the moon, is scheduled to launch on November 14, 2022. Humans will travel the furthest in space ever on Artemis 2, a crewed mission beyond the moon, and Artemis 3, a mission that will send the first female and first person of color to the moon, will conduct research on the lunar surface for a week. Since Apollo 17 in 1972, Artemis 2 will be the US Space Agency's first crewed moon landing mission. The long-term objectives of NASA are much more ambitious, even if the Artemis space missions are primarily focused on lunar exploration. NASA plans to fly a crewed mission to Mars in the future using the technology and science produced by the Artemis space flights. A new space station will be constructed in lunar orbit as part of NASA's ambitious Moon-to-Mars plan, and a facility on the moon will eventually become livable. The twin sister of Apollo is the lunar goddess Artemis in Greek mythology. Thus, the connection to the mission that sent humans to the moon for the first time 50 years ago is obvious. Orion is the name of the crewed spacecraft currently in development. One of the most recognizable constellations in the sky is Orion, and in classical mythology, Artemis's hunting partner. With Artemis, NASA wants to travel to the moon and stay there, rather than merely attempting to duplicate the accomplishments of the Apollo missions. Even if the main objective is still to send people back to the moon by the middle of this decade, this entails looking into the feasibility of setting up bases both in lunar orbit and on the lunar surface. By 2024, NASA's initial declared objective was to put people on the moon. However, the agency said in November 2021 that this date would be delayed until no earlier than 2025. Even this timetable is not guaranteed. According to NASA Inspector General Paul Martin, the crewed lunar landing will probably happen no earlier than 2026. The third phase of a multi-year mission that began with Artemis 1, an unmanned trip around and beyond the moon, is the landing. These missions all have aggressive completion dates. Okay, now that we've overloaded you with information about Artemis, you'll understand the need to develop a resistant coating. After 6 months of sun exposure on the ISS, the sample coating will be evaluated for durability. University engineers will batter the sample with lunar dust once it has returned to Earth to assess how well it holds up in that tough environment as well. One issue the covering might encounter on the moon is radiation. Materion, a global leader in advanced materials, cites a few characteristics of the space environment. including atomic oxygen and micrometeorites that can erode protective shielding on space constructions. The International Space Station has been hard at work. Anticipating that additional material developments might be required, a number of dedicated exterior facilities on the American and Russian sides are burning the midnight oil. They'll evaluate how well materials will withstand several months of space exposure. But if you're still puzzled by what erosion is and why is it a cause of concern, we'll run you through the basics. The effects of corrosion in orbit are greatest for spacecraft with moving parts. Early satellites frequently experienced issues with losing their bearings. Now, a small layer of gold is applied to the bearings. Different materials have varying levels of space corrosion resistance. Atomic oxygen, for instance, slowly corrodes aluminium, whereas gold and platinum are more resistant to corrosion. Therefore, to shield the spacecraft from the hostile environment, gold-coated foils and small layers of gold are applied to exposed surfaces. Metals can also be shielded from the effects of atomic oxygen by having thin coatings of silicon dioxide coated on their surfaces. For instance, the Starshine 3 satellite's aluminium front mirrors were shielded in this fashion. However, micrometeorites have the potential to erode the protecting layers. The progressive erosion of the silver was shown to be the cause of several recorded in-orbit failures. Silver accumulates a layer of silver oxide, which tends to flake off and serves no protective purpose. Atomic oxygen and ionizing radiation have a significant impact on the sensitivity of many polymers. Especially for plastics, atomic oxygen-resistant coatings are a frequent form of protection. Due to their remarkable resistance to radiation and atomic oxygen, silicone-based paints and varnishes are commonly used. However, the silicone's endurance is somewhat constrained because of silica, which is fragile and prone to cracking, developed on surfaces exposed to atomic oxygen. Now, if you thought that we're done, you've yet to learn who the real enemy is. The existence of a cloud of pollutants around the spacecraft is caused by the outgassing of volatile silicones on low Earth orbit electronics. Okay, outgassing sounds like a fancy word, but it just means the release of a gas that has been dissolved, imprisoned, frozen, or absorbed in a substance. That may result in the slow deposition of thin layers of silicone. In the case of optical devices and solar panels, their lack of transparency is a worry. The Mir space station's solar panels showed deposits on them after 10 years of use. Other issues for structures exposed to space include material degradation and redeposition brought on by sputtering from rapid atoms and micrometeoroids. Although not corrosive, material fatigue brought on by repeated heating and cooling, as well as the resulting mechanical stresses from thermal expansion, is another key issue. High-energy particles from the Sun, belts of protons, electrons, and ions gathered within Earth's magnetic field, and an exotic collection of cosmic rays from outside the solar system are just a few sources of radiation that fill the space beyond Earth. Satellites have always had a problem with radiation. Telstar 1 was a high-profile early casualty in 1962 because its transistors degraded as a result of traveling into the inner Van Allen radiation belt. Standard integrated circuits will gradually deteriorate or perhaps fail catastrophically when exposed to the radiation environment in space. Hence, satellites must include radiation-hardened components. The problem that troubles our space technology-savvy community is figuring out how to continue using cutting-edge terrestrial technology in space. Their ultimate goal is to increase the capability of future missions while maintaining reliability. Of course, we're going to be eager to hear news of the mission's success at the 6-month mark. With the rate at which current economic tensions ripple through Earth, it makes sense to build a home on the Moon.